Hey everybody, welcome back. Our last lesson was pretty fun. We got to learn how to graph in 3 dimensions, or at least start to learn how to do it. Today we're going to learn how to solve systems of three linear equations. Remember, they can intersect like a TP and have no intersection. They can intersect all in a line like a book, or they can intersect in a single point. So let's see how it works out. All right, so we're going to take the process for solving a system of equations of two e- two equations. We're just going to extend that process to do it in three. So again, we can use substitution or elimination or any combination of two. We could do a substitution to start and then come in with elimination. I'm going to start with elimination on this. So the way I look at this is that if I were to add the middle two equations together, I could eliminate the y's. So that's exactly what I'm going to do, and I'll just simply put the results right here. So let's add the middle two equations because they're already set up to get rid of y's. When I add them, I get x plus x is 2x, negative y and y cancel, and z plus z is 2z, and negative 7 plus 5 is a negative 2. As you can see, there's a 2 in each one of these terms, so I'm going to make it easier on myself and just divide everything by 2. Perfect. Now, I'm going to try and eliminate y's in two other equations. So let me make this very clear. I eliminated y in the top two equations. I need to eliminate y again. Even if I have to multiply an equation or multiply two equations, it has to be y, and it has to be two different equations. Now, clearly, one of them will be used twice. And in fact, I'm going to use the middle equation twice. But at least it's a different combination of the two, right? Because I need to get a different equation. So when I add these two together, I'll get 3x. I'll use red so you can see that I'm doing it here. 3x. Let's see here. Z minus, that's minus 2z is equal to 12. So I now have a system of two equations and two variables. I'm going to take this equation here and this equation here, and I'm going to solve a system. So I have 3x minus 2z equals 12. Now, I said I'm going to use this, but I may have been a little bit trigger happy dividing this equation by 2 because it turns out dividing it by 2 wasn't the great idea. I should leave it times 2 because then the z's will cancel. So if you'll permit me, I'll just do that. So that's just this equation times 2. Now I'll add these two equations together and the z's will cancel and I get 5x equals 10, which tells me that x is 2. Now I know what x is. Let's go find what z is. I can use any one of these equations, including this simplified one. So I'll use this simplified one. I just need an equation from my two xz equations. And I get z equals negative 3. Now that I know that, let's find out what y is in one of the three original equations. I'll use the middle one. So I'll say 2 plus y minus 3 equals 5. And that gives me y minus 1 equals 5, which gives me y equals 6. My answer is an ordered triple. That's my solution, an ordered triple. X comma y comma z. And I can plug each one of these in and see that they work in all three equations at the same time. 2 minus 6 is negative 4, minus 3 is negative 7. 2 plus 6 is 8, minus 3 is 5. 4 minus 6 is negative 2, plus 9 is 7. It works. All right. Now, let's do another example. All right, on this one here, I've got three equations, but some of the equations are missing some variables. And this, depending on how you do it, you might get lucky and save you a little bit of work. But oftentimes it turns out it really doesn't save you much work. I need to get the two equations with the same two variables. Unfortunately, these bottom equations have x, y, and y, z, so that's not going to cut it. I am going to use this equation and this equation, and I'm going to add them together. When I add them together, I get x, there's no other x, plus 3y, and the z's cancel out, and 1 plus 3 is 4. So I need to make sure that I have another equation that has only x and y. Well, I actually already have that right here, so I'm ready to use that. So I'll use x minus y equals 0. I'll multiply the top equation by a negative 1, making this negative x minus 3y equals negative 4. And I left the bottom equation the same. When I add the two equations together, I'll get a negative 4y is equal to a negative 4, so y equals 1. Now that I know y equals 1, the middle equation, I can solve and get x equals 1 as well. Now that I know that x equals 1, I can use the top equation, or the bottom if I wanted. 1 plus y was 1 plus z is equal to 1. So 2 plus z equals 1, so z equals negative 1. So my ordered triple is 1, comma 1, comma negative 1. You can check. Clearly it works in the top equation. 1 plus 1 minus 1 is 1. 1 minus 1 is 0. It works in the middle. 2 times y, so 2 minus a negative 1 is 3. So 3 equals 3. Okay, it's time for you to do a practice problem. Pause the video. Don't give up. Don't stop early. You can do it. Just be careful and make sure you check your answer. Even if you have to go back and make some changes, check your work by plugging in the values. All right, let's see how you did. Unfortunately, I can't really do it the way you did it because I don't know which equations you used or which variable you tried to get rid of. So yours might, if we get the same answer, great, but you might have done it a different way than me, and that's totally fine. Well, the first thing okay, this one is a little weird. You know I love to throw curveballs at you, right? First of all, let's move the z over to the other side is what I would do, probably. Although you could use substitution because we've got negative x plus y is equal to z. You could replace that right here. But when you do that, what you end up getting is, well, I don't know. I think that works pretty well. So I could do it both ways. But you could also just move the z over and then you have it like that. And then if I take that equation and I add it to the bottom equation, something weird happens. Okay? And I wanted to go over this. Some of you may have solved this problem and like, what are you talking about weird happens? Maybe you did the substitution, or if you eliminate like x's, I think, it works just normal. But I do want to go over this weird thing that can happen. So when I add these two equations, look what happens. I lose both variables. And when I do that, I end up getting negative 2z is equal to 4. And that gets me z really quickly, right? But here's the deal. If I plug in z to one of if I plug in negative 2 for z in these two equations here, I'm not going to get a system I can solve because the x's and y's are in the same scale. This xy and this xy are just multiples of each other. So I'm not going to get a solution that I can solve. I'm going to get two parallel lines. And you might think, oh, that means no solution. It doesn't, because I got z equals negative 2. So that's a weird situation. When the two variables both cancel out at once, it seems like you're getting the answer really quickly, but you're not. You're actually going to have to do just as much work, and that happens a lot. So what I'm going to do instead is I'm going to use this middle equation, because the middle equation is a totally different equation than these two, and I'm going to plug in for z there. Because, again, if you don't believe me, plug in negative 2 for z and then try and solve this system. What's going to happen is you're going to get 2. So you'll have negative x plus y equals negative 2 when you move it over. X minus y equals 2. And then they're the same line, right? So let's go and let's plug it in over here. So I have 2x plus 2y plus 3 times z equals 2. So that's 2x plus 2y minus 6 equals 2. That's 2x plus 2y equals 8. And then I'm just going to divide by 2. Last time I did that, it didn't help me, but I think it will this time. So I have x plus y equals 4. Now what I'm going to do is I'm going to use this top equation, and I'll use that. So I'm using the top equation. I'm just going to put it right here. Negative x plus y equals z. Z was a negative 2. Now when I add these two equations, they're not the same line, and I get 2y is equal to 2. So y is equal to 1. So we definitely can get a y value. So just be aware that if you get infinitely many solutions when you had both variables cancel out, and if you got one number here, then you shouldn't get infinitely many solutions. If you do, you have to use a different equation. So I have x minus 1 minus z. So that'd be plus 2 equals 4. So x plus 1 equals 4, so x is equal to 3. So our solution is 3, 1, negative 2. All right, that being said, there are times where you can get infinitely many solutions. Let's take a look at this next one. And I think if memory holds from doing this before, this is the one that should give us infinitely many. So let's see what happens when that happens. Or no, I don't know if it's infinitely many or no solution. Actually, I can't remember. I am going to add these top two equations to get rid of z. So I have 6x plus 3y equals 10. And then I'm going to multiply this equation by negative 2. No, just by 2. So I have 8x plus 2y plus 2z. No, not plus 2z. Minus 2z is equal to 4. We're multiplying by 2, right? And then I have negative 2x plus y plus 2z equals 6. I add these two equations together, and I get 6x plus 3y equals 10. Now, this is a very different situation. I've got two equations, and they are exactly the same, and I did not cancel out a letter, two letters at once, and find a value. This here, y'all, this is going to be infinitely many solutions because they're the same line. So we're going to say infinitely many solutions. And the truth of the matter is that infinitely many no solutions are difficult to figure out when doing it like this. So most of the time, I'm going to want to give you problems that have real solutions. When we learn some new techniques in the next unit, it's going to make problems like this so much easier. All right, let's do one more practice problem, and then I think we're all done. All right, give it a try. All right, so on this one here, I'm going to add the bottom two equations. Again, you may have done this differently, but I'll get 3x plus 3z equals 7. Then I'm going to multiply the middle equation by 2 and add it to the top. Because I like having that negative z, so that makes things easier for me. So I multiply the middle equation by 2. I get 2x minus 2y plus 2z equals 2. And I'll add them together, and I get 3x plus 3z is equal to 2. These two lines are clearly parallel. They have the same slope, but they are not equal to the same constant. This is no solution. So that's when that happens. When you get the system that can't be solved, you know it's either no solution or infinitely many. So that's the end of our lesson today. You just need to practice these a lot, y'all, and be really, really careful. And please plug your X, Y, Z back in. Check your work. All right. Until next time, take care.